So this user says a chroot jail in Linux is a technique that changes the apparent root directory for a running process. The comment goes on to talk about how it restricts your access to like that specific directory and its subdirectories of wherever your chroot is. I want to do a long form video about this in the future because chroots are so interesting. When you hear the name like chroot jail, you immediately think like, oh, it's a jail, it's locked down, it's secure. And that's kind of true, but also kind of not, because there's some weird quirks with it. You can use like the chroot command to, which will call the underlying chroot syscall for you, but you can chroot yourself into any sort of directory. I could chroot myself somewhere and then run some command in that directory. It'll probably fail because you'll need some sort of directories there that normally exist in your root. You might need some files in /dev. You're going to need maybe the /proc if you're in like Linux or something. You'll probably need the /sys directory. So what you'll have to do is create these bind mounts for them. On Unix, you can't have hard links of directories unless they're like dot or dot dot. Those are the two exceptions. So you have to do, on Linux, it would be a, what is it? I think it's a bind mount. On like a Lumos, it'd be a Lofus mount. Long story short, you'd have to basically copy the directory over there, which creates like a mount for it that you can access all the files, the same as if they're on /. So then it looks like its own little operating system. You might have to put some shared libraries in there for whatever commands you're going to execute. That's all well and good, but thinking of it like a jail can be problematic because, of course, if you've done like basic like hacking 101, there's like how to break out of a chroot jail. And it's surprisingly simple because it's not like a layer of virtualization or something. It just changes the apparent root of the process. There's some sort of process struct that your kernel will have for every single process on the machine, and that process will have what its active root is set to, just like it knows what the UID of the process is and certain things like that, the current working directory. So for its root, for most processes, is going to be /, but for your chrooted process, it's going to be somewhere else. If you were to chroot again, it doesn't just layer a new jail on top of it, it just changes that single parameter. So if you were to, the example is you go into jail, you open up a file handle somewhere in that directory, you go deeper into another directory, change your chroot to that new deeper directory, and then fchdir your way out to that open file handle you have, and then suddenly you're outside of the jail and you can go around. Don't cd the / because you'll go right back into jail, but you can go ... until you get to the root directory. You can check that by looking at the inode numbers of ... and ... making sure they're the same, blah, 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 blah. My point is, I think this would be a fun long form video because there's a lot of weirdness with chroot. There's a lot of ways to break out of it because I don't think it was ever intended to be like a jail. I could be wrong there, maybe it was, but it doesn't seem like that's its intention. It just seems like this is the apparent root of a process and we can change that. This can be useful for all sorts of things, like this comment is referring to a web server. There's a perfect example of when to use a chroot or something like that. But now we have containers and stuff, and yeah, that's it.